Everyone for joining us today on the webinar. And I hope people would be excited enough to know one of the important aspect and subject which we regularly talk during our work site visits or either we are in the offices. It's all about scaffolding, right? So today I have with me uh, one of the fantastic person who can showcase more about the components and the usual talk which we do. We'll be learning more beyond the usual about leaving about the scaffolding component parts or like how we erect it. uh, we'll be focusing on this webinar about the engineering related aspects. So with me today, Madhukar Tiwari is the speaker, and he has good like rich experience of 15 years. He worked in construction, aluminium, oil and gas sector. He has also have very good experience, head-on practical experience in working at height, rescue, confined space entry, and he has also developed scaffold management system for numerous company in his past organizations. And he also have a good exposures and knowledge about OSHA standard. If we talk about his education path, then he hold mechanical engineering degree uh, and also many other HSC courses from other reputed institute from India and abroad. So this was all about from my side, and to just give you a brief about IISM India branch, what we are doing currently and what we are going to in the upcoming month. So recently we have uh, talked to one of the universities, and we are further having a collaborations in India in one of the top-notch universities, and there are lots of events and programs we have aligned. So definitely we'll be getting to know about all those in our LinkedIn page and monthly newsletter from IISM. And again, in the upcoming month, we have two different webinars scheduled, and about those, the timing and the topic would be shortly shared in our LinkedIn page. So if any one of you, those are not the member of IISM and want to join IISM, then definitely you can reach out to us directly through the IISM website or LinkedIn page, or you can reach out to me, Mohit Sharma. I am currently chairing IISM India branch. So this was all about from IISM India branch. And now I'd like to hand over to our speaker, Mr. Madhukar Tiwari. Thank you.
Thank you, Mohit and Sujan. Good evening, good afternoon, and good morning. First of all, I would like to thank IIRSM team for this opportunity, and a special thanks to Mr. Mohit Sharma and Sujan for making this possible and provide me such prestigious platform to share my knowledge. Friends, today I'm going to speak about design and basic engineering principle of industrial scaffold. As we know, scaffolding is one of the very important aspects for the industries, especially for the construction industry. And scaffolding helps in many ways to perform the activity at height in safe manner. However, unsafe scaffolding design can cause injury, even death. This session will help with discussing general requirement of scaffold designing and inspection. In addition, because you are going to spend 1 hour with me, so what would be the outcome from these presentations? The first outcome will get the idea about the engineering dimension of various type of scaffold. Next, we'll get the idea about safety factor which help during the designing. That is very, very important. What would be the safety factor? And last one, we'll get the designing formula of scaffolding. So these are the significant major outcome from these presentations. And this presentation totally based on the concept of engineering. As you know, At present, several types of scaffolding are being used worldwide, and each type of made of several components, which include base plate, ledger, transom, vertical, clamps, and many more components. Okay, now we're going to discuss about types of scaffolds. A scaffolding divided into three categories: in nature of design, in nature of load capacity, in nature of mobility. In nature of design, a scaffolding divided into two parts. First one is the tube and coupler scaffold. What do you mean by tube and coupler scaffold? Tube and coupler scaffold consists the steel tube and clamps to form the structure, and this is the one of the oldest scaffolding of the world. And second one is the fabricated scaffold. This scaffold, also called the modular scaffold, and many construction site people are using these scaffolds such as coupler systems, layer systems, or H-frames. In nature of load capacity, a scaffolding divided into three categories: light duty, medium duty, and heavy duty. What do you mean by light duty? As per OSHA guidelines, OSHA says light duty scaffold can carry 120 kg, approx 122 kg weight per square meter, and you can perform the light work on the scaffold. Medium duty scaffold carry the medium load, approx 244 kg per square meter, and heavy duty scaffold can carry the heavy load 366 kg per square meter. We'll discuss further designing parameters of light duty, medium duty, and heavy duty scaffolds. In nature of mobility, there are multiple types of scaffolding nowadays. There are many types of scaffolding. Supported scaffolding supported from the grounds. Then come to suspended scaffold. Suspended scaffold suspended from the structure. Next one is the cantilever scaffold. Cantilever scaffold extended from the edge. And next one is the mobile scaffold. Mobile scaffold can move anywhere on the surface. So these are the classification of a scaffold, and further will be discussed about the designing parameters of all various type of scaffold. See, next one about the important terminology of a scaffolding design. First one is the bay length. Bay length is one of the very important concept for the designing. And if you're talking about the bay length is the distance between two verticals. Bay length is the distance between two verticals. Second one is the bay width. See, friends, a scaffolding is the always rectangular. There is a length and width. The length side is the bay length and width is the transom. The bay width is the shortest dimension of the scaffold. That is very, very important to understand bay length and bay width, because during the design, this is the very, very important. Second one is the bay height. Bay height measure from the ledger to ledger. You can see from the picture, bay height measure from ledger to ledger. And next one is the transom. Transom is the load bearing components and all the planks, board seated on the transom. Next one is the ledger. Ledger provides the lateral support to the scaffold. Extender is the vertical member. Base lift fitted in ground floor 150 millimeter above from the grounds, and base plate consists the laser transforms all the components. Bracings provide the rigidity to the scaffold platforms where people and material can support, and guardrails prevent from the fallings. So there are few parameters of the designing. So while you are designing the scaffold, you must consider these all points: bay length, way width, height, transom, laser, extender, base lift, bracings, platform, and guardrails. See, according to OSA guidelines, if you see the OSA guidelines, OSA says every scaffold and scaffold components shall be capable of supporting without failure its own weight. That means dead load. What do you mean by dead load? Dead load is the self weight of the scaffold and at least 4 times of the maximum intended load. So what is the important in this slide? As per OSA, all the scaffold and scaffold components should be supported 4 times of the maximum intended load and dead load. So first of all, let me clear what is the dead load in the scaffold. Dead load is the self weight of the scaffold. Whatever the weight of the transom, bearers, platforms, these all consider as a dead load of the scaffold. Or intended load is the total load of the person, equipment, tools. The two things are very important to understand, because while you are going to design, you have to follow the 4 type of safety factors, right? And intended load. Every scaffold and a scaffold component shall be capable of supporting without failure its own weight, dead load, and at least 4 times of the maximum intended load applied or transmitted to it. And maximum intended load. See, while you are designing the load capacity, load of the scaffolding, that formula is very helpful: D plus 4 into IL. What is the D, what is the 4, and what is the IL, and how we can design the scaffolding considering this formula, that is very important. First things about the D. D is the dead load of the scaffold, means self weight of the scaffold. 4 is the factor of safety, and IL is the intended load. In IL, you have to consider the man, machine, and materials, and 4 is the safety factor. So 4 and IL will multiply, and whatever the D will be added in this result. See, when you are going to design the scaffold, first you have to determine the dead load of the scaffold. What would be the dead load of the scaffold? For example, tubes, clamps, planks, platforms. Next, determine the live load or intended load of the scaffold. Next, gather the all formula from the above. Next, you gather all the informations and put in the formula. You can see from here, if there are 4 people going to perform the activity, you have to consider the each people 100 kg, because OSA says people to people weight vary. As per standard, you have to calculate the 100 kg for each person, and if they are going to carry 120 kg and material 80 kg, so now there is a intended load is the 600 kg. I think you clear what is the intended load, because when you are going to design the scaffold, so that is very important things is the intended load, get to know. And second one is the dead load. Dead load is the 100 kg, maybe it will change. So according to the formula, 600 is your intended load. 600 multiply with the 4, the result is 2400 kg, and plus 100 kg is the dead load of the scaffolding. The total designing will be 2500 kg, and you are only you are going to deposit the load on 600 kg. This scaffolding, if you are designing in that way, then it will be considered the 4 times of the safety factor. This formula is a very important: D plus 4 into IL. The D is the dead load, 4 is the factor of safety, and IL is the intended load. See, Earlier I said there are three types of scaffolding according to the design: light duty scaffolding, medium duty scaffolding, and heavy duty scaffolding. See, what would be the designing parameters for light duty scaffolding? According to the OSA guidelines, light duty scaffold can carry 50 pounds per 25 pounds. Just a minute. Yes. According to the OSA guidelines, light duty scaffold can support 25 pounds per a square feet. And when you are considering in kg, the light duty scaffold can support 122 kg per square meter. So what would be the designing parameters for light duty scaffold? The bay length of the light duty scaffold never ever more than 10 feet or 3 meters. I said scaffolding always rectangulars, right? There is a length and width. So for the light duty, maximum length would be 10 feet. Means distance between two vertical not more than 10 feet. And width, that is totally depend on the requirements. Minimum width would be 4 feet or maximum 6 feet as per the requirements, not more than 6 feet. So OSA says when you are going to design the light duty scaffold, you have to follow this formula. The second thing, on the screen you can see scaffolding pictures. There is a indication of length and width. So when you are going to design the light duty, you must consider the 10 or 6 formula. And maximum load apply on the light duty scaffold 122 kg per square meter. The second, about the medium duty scaffold. Medium duty scaffold can carry 50 pounds per square feet as per OSA guidelines. Medium duty scaffold can support 50 pounds per square feet, and maximum bay length for the medium duty 8 feet. We cannot exceed the bay length more than 8 feet. So distance between two verticals not more than 8 feet. And if you are considering in meter, not more than 2.4 meter. And width minimum 4 feet and maximum 6 feet. So these are the designing guidelines for the medium duty scaffold, and you cannot exceed the weight more than 244 kg per square meter. And this weight is the distributed load, not point load. So when you are working on the scaffold, you always distribute the load on the whole platform. Never give the point load on the scaffold platforms. So what would be the outcome from this slide? For the medium duty, there are two parameters, 8 feet and maximum 6 feet. Width maximum 6 feet and length maximum 8 feet. And and load not more than 244 kg per square meter. Similar for heavy duty scaffold. Heavy duty scaffold designed for the heavy work. And this scaffold can carry 366 kg as per OSA guidelines. This scaffold can carry 366 kg per square meter. And if you are talking about the pounds, so 75 pounds per square feet. And what would be the designing parameters for heavy duty? As per OSA guidelines, you never exceed the bay length more than 6.6 feet. That means 2 meter. And width as per requirement and maximum not more than 6 feet. So these are the designing parameters for light duty, medium duty, heavy duty. So while you are designing the scaffold at your site, you must consider these all three formula related to the light duty, medium duty, and heavy duty. So there is a rules: heavy duty not more than 6.6 feet, medium duty 8 feet, and light duty 10 feet. You always remember these things. Okay. Next, coming to the height and width ratio. That is very important for the scaffolding. According to the OSA guidelines, when you are going to erect the scaffold, you always match the height with the width. See, a scaffolding is a rectangular, right? There is a length and width. As per OSA guideline, the height of the scaffolding should not be more than 4 times of the maximum base dimension. That means width, unless tie or brace are provided. So when you are designing the scaffold and considering the height compared to the width, not more than 4 times. If you are exceeding the limitations, then you must provide the additional tie or brace in the scaffold to provide the stability and rigidity to the scaffolding. See, scaffold tie requirements. When you are discussing about the tie, there are many types of tie. I would say vertical tie and horizontal ties. And when tie required, when you exceed the length and width height more than 4 to 1. A scaffolding tie an important connection that fastens scaffolding to the solid building or body to prevent it from the collapse. Scaffold shall be tied vertically and horizontally. See, there are two rules for the tie. There are two types of tie: vertical tie and horizontal tie. OSA says whenever you are exceeding the scaffolding 4 to 1 ratio, more than 4 to 1, then you must provide the tie. And there are two types of tie. First tie, you are discussing about the first tie. When your width, scaffolding width, less than 0.9 meter, you just note it down. When a scaffold width less than 0.9 meter, you have to provide the tie in two directions. First on the top and second one is the bottom. What would be the ratio for both tie? The tie ratio from the bottom is the 4 to 1. And second rule, the tie ratio from the top shall be 4 to 1. And whatever the space left or gap in between, you have to provide the tie every 20 feet. So these are the rules for the tie. You have to provide the two tie, first one from the ground and second one from the top, and whatever the space left in between, you have to provide the tie every interval of 20 feet. So these are the requirements for the OSA and tie. Second thing about the, if your width is more than 0.9 meter. Earlier we discussed about the width less than 0.9 meter. If your width is more than 0.9 meter, then what would be the tie patterns for that? First tie from the ground, you have to maintain 4 to 1 from the bottom, and second tie from top to down, you have to maintain 4 to 1, or whatever the space left in between, you have to provide a tie every 26 feet. And horizontal tie, you have to provide every 30 feet. When scaffolding the exceed more than 30 feet, you have to provide the horizontal tie. You have to provide the horizontal tie to the scaffolds. So these are the requirements for the tie. See, now bracings. Bracing is the one of the very important components, I would say significant component of the scaffold. And bracing can prevent from the sacking to the scaffold, and also it can provide the rigidity to the scaffold. Bracing shall be provided in two directions, transverse and longitudinal. There are two types of bracings. Friends, you always remember, when you are erecting the scaffold and when you are designing the scaffold, the bracing play a very important role to prevent from the collapse and provide the rigidity. There are two types of bracing. First one is the transverse bracing and second one is the longitudinal bracing. So you can see from the picture what is the transverse bracing and what would be the longitudinal bracings. As per OSA guidelines, there are many patterns of the bracings, right? First one is the zigzag. In transverse side, if you are providing the zigzag bracing, you can take maximum 3 opening of the bay length. Maximum 3 open bay. It is acceptable for the transverse bracings. And longitudinal bracings, we have to maintain the degree of the bracing 35 to 55 degree, and maximum 5 length consider in one shot. Maximum 5 length you can consider in one shot. And if you are using the X bracings, means cross bracings. Cross bracings, as when required, if you are going to erect the scaffolding in wide range for the wide scaffolding. X bracing it also provide the rigidity to the scaffold and prevent the scaffolding from the collapse. So when you provide the X bracings, you can take the minimum 2 gaps in vertically and 3 gaps in horizontally. So depend on the requirements of the scaffolding, you can select the bracings as per the locations, scaffolding size. Normally you will follow the 2 bracings. One is the X bracings and second one is the zigzag bracings. See, in a scaffold design, while you are designing the scaffold, the fall protection is one of the very important concern for the designing. Or each and every OSA says each and every scaffold must, there is a designing provision of the fall protections. So what would be the fall protection for the designing? There is a top rails in guardrail system, mid rails and toe boards. As per OSA guidelines, top rails should be fitted and designed minimum 900 millimeter from the landing platform and maximum 1200 from the landing platforms. So these are the requirements for the top rail. Mid rail would be around in between the top rail and mid rail. And if you are talking about the dimension, the minimum 600 and maximum 750, and toe board would be around 150 millimeters. Each and every scaffold must, there is a provision of fall protection. See, access requirements. Each and every scaffold in design that way, there will be appropriate access. See, for the access, you have to provide the ladder or stairs. When you are providing the ladder for the access, you have must maintain the 75 degree of the ladder. A ladder will be project 1 meter above from the landing platforms. A ladder will not pass over the under guardrails to the gain the access. So what would be the outcome from the access? What would be the guide word for the fall protection and access? 75 degree, 1 meter and guardrails. Each and every scaffold, there should be access and ladder should be positioned at 75 degree, 1 meter and guardrails. A scaffolding design should be easy for the scaffolder to follow and should have. See, friends, if you have informations when you are going to design the scaffold and when you are going to erect the scaffolding will erect in good manner. So what information will require? First of all, purpose of the scaffold. What would be the purpose of a scaffold? Load to be applied to the scaffold. Whatever load you are going to apply to the scaffold. Next one is the dimension of the scaffold, ground conditions, tie patterns, number of board lifted, number of load and working platform at any one times. And last one is the identify of any area of concern, so this can be addressed during the design stage. All a scaffolder should follow these all informations. Okay. Now, specifications of components. See, for the base plate, if you are talking about the OSA, the dimension of the base plate would be around 150 by 150 into 6 millimeter. And plate thickness of the base plate would be around 6 millimeter and shank height would be around 100 millimeter. So these are the specification of base plate. So when you are design, you must mention this specification during design, then it will be okay. When you are talking about the scaffold tubes, a scaffold tube should meet the following requirements as per OSA guidelines. 40 mm nominal bores, 38.3 mm is the OD, and wall thickness would be 3.2 mm, metal grade 240, yield strength 240 megapascal, and tensile strength 410 megapascal. So these are the specification of the scaffold tubes. So when you select the tube, must refer these specification for the scaffold tubes, because a scaffold tube play very significant or important role in scaffolding design. If you select the wrong scaffold tube, there will be accidents or incidents. So these are the specification of scaffold tubes. Next one about the steel board specifications. The maximum width as per EN guidelines, maximum width would be around 225 to 30 millimeter. 225 to 230 millimeters. And side height of the scaffold board would be around 35 millimeter. Metal thickness around 1.5 to 2 millimeters. And planks available in different length and different sizes, starting from 0.6 meter or maximum 2.5 meter. And these steel planks follow the EN standard 10025 2004. See, so these are the specification for the materials which help during the designing. And next one about the guide word for overall designing concept. That is very, very important to understand. First one is the D plus 4 into IL. What is the D and what is the 4 and what is the IL? When you are designing the scaffold, you must focus on three things: D plus 4 into IL. D, the dead load of the scaffold. The first, when you are going to design the scaffold, first you get the information about the dead load or self weight of the scaffold. Once you get the information about the dead weight or self weight of the scaffold, then what would be the intended load? Means what load you are going to deposit or apply on the scaffold. First you get the intended load, and then you have to apply the 4 time of safety factor. So these are the key of scaffolding designing: D plus 4 into IL. Intended load, as I said, intended load is the man, machine and materials. You have to add all the load, and whatever the result will from the intended load. See, according to the classifications, according to the design classifications and load capacity, scaffolding divided into 3 categories: light duty, medium duty and heavy duty. Light duty scaffold, maximum designing bay length 10 feet. And what would be the load? 122 kg per square meter. Means these are the very, very important to understand. If you are going to design light duty, maximum bay length is 10 feet and weight per square meter 122 kg. For medium duty, maximum bay length is 8 feet and weight 244 kg per square meter. And for heavy duty, maximum bay length is 6.6 feet and 366 kg per square meter. There was a mistake in presentation. 366 kg per square meter. See, what is the bay length? Bay length is the distance between two verticals, and always measure from the front side, right? So when you are going to design the bay length, you have to measure the bay length distance from the standard to standard, vertical to vertical. Bay height should be measured from the ledger to ledger. And tie requirements, there are 2 types of tie: vertical tie and horizontal tie. Vertical tie should be tie from 4:1 ratio from bottom and top, and horizontal tie every interval of 30 feet. You have to provide the bracing, either zigzag bracing or cross bracing. Also in a scaffold design, there should be provision of fall protections and access. Fall protection, that means top rail, mid rail and guard rails, top rail, mid rails and toe boards. And access, if you are providing the stairs, either you are providing the ladder, you provide the appropriate ladder in appropriate position. You have to maintain the 75-degree ladder should be 1 meter above from the landing platform. And ground condition is also concerned for the designing. And last one is identify of any area of concern so which can be addressed during the designing stage. So these are the guide word for the scaffolding designing. These all parameters should come in designing and you have to consider during the designing. See, last one is the scaffolding inspection requirements. According to OSHA guidelines, each and every scaffolding before first use must be inspected by a scaffold inspector. When you erect the scaffold as per the design, that a scaffolding must be inspected through a scaffold inspector. Second one, at least what would be the frequency of inspection? At least once every 7 days, the scaffolding should be inspected once a week, every 7 days. And apart from that, after any modification or repair to the structure, if you are doing the any modification in a scaffold structure, again subject of inspection. They have to perform the inspection after any severe weather that may have damaged the scaffold. Any potential damage, severe damage, you have to again subject of the inspection. The second things about the scaffold inspection, a scaffold that are approved to provide safe for use, you have to put the green tag in place in each access point to clearly show the scaffolder user to a scaffold is safe for use. And scaffolding which are not safe provide the red tag. All scaffold inspection will be recorded on the scaffold tags. OSHA says whenever you are when you are inspecting the scaffold, must be maintain the record on the registers. And during the inspection, you have to also identify the any area of concern, hazards related to the scaffold. So these are the inspection parameters of the scaffold. Right. So now, actually, due to the time concentration, presentation is over. If any question from the anyone, I'm happy to reply. Sujan.
Yeah. Thank you. Thanks for your presentation.
Thank you, Madhukar. There's some questions
Sujit,
that
I'm
come
taking the
through.
questions. Yeah.
Yeah, so one of the first question was, what all load can be included in dead load? Can we include the ladder weight also?
In dead load, we cannot include the ladder because ladder supported from the grounds. The OSHA says ladder and vertical member who can support it from the grounds, who supported from the grounds, no need to add in dead load.
Okay, thank you so much. Another question is there acceptable bamboo wood scaffolding in construction industry? If yes, what standard applicable for bamboo scaffolding?
See, for the nowadays bamboo scaffolding is not acceptable across the world, and according to Indian standards and ILO scaffolding, bamboo scaffolding no need to use.
Thank you. Another question is, what is the overall safety factor for scaffolding design?
See, while you are designing the scaffolding, you have to maintain the 4 times of the safety factor. As per OSHA guidelines, OSHA says each and every scaffold and its components should be supported 4 times of the maximum intended load. The intended load you have to consider the man, machine, and materials. And whatever the intended load you are going to deposit on the scaffold structure, you have to maintain 4 times of the safety factor.
Okay, and it just followed up with another question. Can we use a personal fall arrest system along with guardrails of the scaffolding?
See, as we know, a scaffolding is a temporary structure, right? You must use the fall protection system like full body harness. But while you are designing the scaffolding, you must consider the guardrail system, and guardrail system consists the top rail, mid rail, and toe boards.
Another question is, could you please explain about the fall protection design guide?
See, in fall protection design guide, as per OSA guidelines, you have to provide the guardrails. What would be the height of the guardrails for the top rail? Minimum 900 and maximum 1200 millimeters, and for mid rail minimum 600 or maximum 750 millimeters, and toe board around 150 millimeters. These are the guidelines from the OSA while you are designing the fall protection in a scaffolding.
Thank you. Another question is, safety harness is recommended to work on safe scaffolding. If yes, can you provide standard or compliance requirements?
See, why safety harness is required on the scaffolding? Because the scaffolding is a temporary structure. This is not permanent structure. When you are going to perform the activity on the temporary structure, you must wear the full body harness and fall protection systems. That's it.
Okay, another question is, if you can just expand more on coupling.
Sorry?
If you can just expand more on the planks.
Yes, planks. If
Planks
you're
and
discussing
coupler,
about
both the questions.
Sorry?
Planks and coupling. Planks and coupler, about coupler also, coupling, what type of couplings and planks?
Yes. Okay, there are two questions. One is the planks and coupling. There are different types of coupling used in a scaffolding, starting from the 90-degree fixed coupler. That coupler make the connection in 90-degree, then swell coupler, joint box, swivel coupler. There are many types of coupler in a scaffolding. And when you discuss about the planks, the plank length would be maximum 250 millimeter, 2.5 meters as per EN guidelines, and width would be vary from 225 to 2230, and metal thickness starting from 1.5 and maximum 2 mm, and per square meter capacity of the metal planks would be around 350 kg as per EN guidelines.
Thank you. Manhukar, another question is, can we connect our lanyard with the guardrails of the scaffolding?
See, that is a very conditional questions, because as per OSA guidelines, you have to provide the appropriate anchor while walking at height. And guardrail is not considered as anchor. Guardrail is the part of the fall prevention. When you are talking about the working at height, the working at height divided into two sections. One is the fall prevention and one is the fall arrest systems. Where fall prevention is already installed, fall arrest system not required. But a scaffolding is a temporary structure. You can use different anchor while walking on the scaffolding, and this is also acceptable to anchor your harness to the guardrail. This is also acceptable.
Thank you very much. And another question is, what are the material construction of the scaffolding pipes?
See, construction of the material, when you discuss about the material specifications, carbon steel, and that was the galvanizing. And if you are talking about the thickness, so there would be approx 3.2 mm, and yield strength 310 megapascal, and breaking strength 410 megapascal.
Okay. Another question is the yellow tag line, and what does it mean?
Yellow tag, that means, see, in a scaffolding there are two systems. You have to put the green tag. Green tag, that means the green signal. The scaffolding is the safe, and red tag means it's scaffolding unsafe, right? If there is a yellow signal, that means the scaffolding is under progress.
Okay. And another question is, are there any reasons that scaffolding collapse?
there are multiple reason why a scaffolding collapse. First one is the designing parameters. If you are not meeting the designing parameters, right? If you are erecting a scaffolding in, base is not in good enough. If you impose the, if you cross the SWL, if you are not considering the safety factor while designing, there are multiple factors of the collapse.
Okay. Another question is there any load test required after erection of scaffolding?
Now, if you have followed this dimension, because if OSA and Ian suggested for light DFT 10 feet maximum bay length, for medium DFT 8 feet maximum bay length, or heavy DFT 6.6 feet maximum bay length. So these all are tested. Just you follow the specification of the materials, and you have to maintain the dimension, whatever dimension recommended from the OSA and Ian. Then you have to perform the activity without testing, because already tested. If they are provide the weight for the light DFT, medium DFT, and heavy DFT, already there is a R&D, and after that they are publish the specification standard. Light DFT can support that much kg, and medium DFT can support that much kg, and heavy DFT that much support that much kg. So no need any kind of testing. Keep you erecting as per the procedures.
Okay. Another question is how can we calculate a safety factor for rescue structure? What is the capacity of one ledger?
See, when you are going to perform the rescue, in rescue there is a very important factor is the anchor point. Where are you anchoring? The scaffold ledger is not an anchor, right? If you are going to use a scaffold extender or ledger as an anchor, then you have to provide the additional support extender, additional vertical near to the anchor points, and get tested. Then you can use as a rescue points. Because if you see the specification, the anchor should be supported at least 2,300 kg. Anchor point should be supported to 2,300 kg, and means when you going to perform the rescue, must confirm that a structure should be capable for that much capacity or not.
Okay, thank you. Another question is what is the distance of a mid rail from top board, which is approx 600 millimeters? So is it a standard or changes according to requirements?
See, OSA also recommended if you are not meeting the specification, then you can do the changes, not issue at all, but you can do the changes under supervision of competent engineer. If you are not meeting the requirements 600 or 1 meter, you can change the specification, but the guidance of the competent engineer.
Okay. Another question is what are the hazards of a scaffold? I think you covered it on the another question, so I don't know if you want to answer that again.
Sujan, can you repeat once again?
Yeah, so it's a question on the hazards of a scaffold.
See,
so what are the main hazards?
There are many multiple hazards related to the scaffolds, and when people get exposed part of the scaffold, I would say improper construction is the one of the significant hazards. Not providing fall protection is a significant hazards. Damaged components, substandard material, these are the significant hazards related to the scaffolding. Because of these hazards, people can fall from the scaffolding.
Okay. Another question is what is MPA?
Sorry.
A question is what is MPA?
Megapascal.
Okay. So another question is a spare OSHA standard size of a plank. I think that's just a comment actually, so I do apologize. So another question is third-party inspection is mandatory for scaffolding or should be done by component person only?
No, for the scaffolding inspection, third-party certification is not required.
Yeah.
A scaffold inspector who having the good experience and holding the certificate, they can inspect the scaffolding. That's it.
Okay. And another question is, please could you tell me about the cantilever scaffolding and barricade scaffolding?
See, cantilever is scaffolding extended from the platforms. And when you are going to design the cantilever as scaffold, you have to maintain the proper counterweight, right? And there are 2-3 things is very important when you are going to design the cantilever as scaffolding: projection length and tailing length. How much length you are going to project of the tube, and what would be the tailing length, and what would be the counterweight. You have to maintain the 4 times of safety factor for the counterweight, and projection not more than 2 meter. Never ever. Projection not more than 2 meter for the cantilever scaffold, and cantilever scaffold should be properly supported with swell coupler. That's it.
Okay. Right. I think that is all for the questions. Mohit, I'll hand over to you so you can close the meeting.
Sure. Thank you, Susan, for taking up the questions. And yeah, wow, it was like such a brilliant session, and there were too many questions and good number of participation, around 75 were there in the session. And definitely I enjoyed the session about the scaffolding, what especially in construction field majority of the work, or I would say the strength in construction field is we are seeing like lots of scaffolding everywhere here and there. So I hope like what I have enjoyed the session and got the idea, which going back to the site I can use some of the brilliant tips inside what I've learned from this session. Likewise, all the audience member would definitely would have enjoyed the session, and they would have also got the good insights. And that's it. Thank you everyone, and to our speaker for sparing your time and presenting the wonderful insights about the scaffolding, focusing majorly more on engineering part. So that was all about today's session, and I thank you to all the participants joining across the world. I can see like lots of people like across the world they have joined, and once again thank you, and we'll be joining in the next month on the different topic, different sessions, and the different speaker. Thank you, Suzanne. Thank you, Madhukar Tiwari.
Thank you.
Thank you,
Thank you,
Mahukar.
Mohit
Thank you,
and
Mohit.
Suzanne.
Thanks everyone for joining us. Goodbye.
Bye.